Good day, I am Peter Rony and I live in Blacksburg, Virginia. The title of this YouTube video includes two questions. Why were Bugbooks I and II successful? And the second question sort of provides an answer. Because of my Leroy-lettered images, question mark. We'll see from the rest of the thing. Now, my first attempt at creating experiments was a workbook for 15 chemical engineering students who took a laboratory course starting February 1974. I want to show you two images that I call examples of physical wiring diagram on a solderless breadboard. Here it is. I think what I did was somehow make a copy of the DigiDesigner top, and then I drew lines that represented wire connections on the top. And here they are. Now these two images and several others that I will show you appeared in my Introductory Experiments in Digital Electronics workbook, 177 pages, used only by 15 chemical engineering students. Only. And I call this 177-page manuscript pre-Bugbook. It's part of history. If you try to tell Bugbook history and omit this manuscript, you are doing a disservice to the public. I will not accept such a disservice. Okay, now let me show you in contrast two slides where I provide examples of wiring digital circuits directly from schematic diagrams. It was my decision to transition my students to this capability. I made the decision, nobody else told me to do so. Well, here are some pen and ink images of integrated circuits. Figure 3.1.2.1.7.3 are images, and this is just how the functions appeared on these little black thingies called integrated circuits. And in the upper right, I show you the pin configuration of a segment display. Well, if this is all I show the students, it's not good enough. Terrible. So what did I do? I showed students what I call schematic diagrams. And here are pen drawings of 3 circuits, actually 4, and the only ones who saw these hand-drawn images were my chemical engineering students in February 1974. Now, take a look at the upper left. This is an integrated circuit. Look inside the box on the left side, and you see pins from top to bottom in the following order: 9, 10, 1, and 15. These are inputs. And then below you see pins 11, 14, 5, and 4. These are control signals. Moving to the right-hand side, within the box you see pins 7, 6, 2, 3. These are outputs. And then at the bottom 13 and 12, which are control outputs, and you need power to this integrated circuit, and at the bottom I show you power, 8 with the ground symbol and 16 with plus 5 volts. By the time I finished the spring 1974 quarter, I expected my chemical engineering students to be able to wire circuits on a solderless breadboard directly with these types of schematic diagrams. I don't know if that was an innovation, but that's what I felt was appropriate, and I made the decision that I must transition my students to these types of diagrams. And by the way, my book, Introductory and Experimental Digital Electronics, was pre-Bugbook. And if you compare these images to the ones I drew with a Leroy lettering set in Bugbooks I and II, you will see the origin of the diagrams in Bugbooks I and II. So I'm showing you Bugbook history. Actually, up to this point, pre-Bugbook history. Now I would like to proceed to some images from Bugbook I. And here's how I did those images. No longer did I have rather crude pen hand-drawn images. I used a Leroy lettering set. And I used this set to draw all of the schematic diagrams images in Bugbooks I, II, 2A, 3, 5, and 6. You can imagine it was time-consuming to draw such diagrams, and I estimate that to do so in the 3 Bugbooks took me at least 1 full man-month. Well, there's something important to add. We gave no lectures to my winter quarter 1974 chemical engineering students. Why? Because the images were lousy. Now, with Bugbooks I and II, the images were excellent. Dark lines, easy to project, and individuals at the back of a room could see them. So, my Leroy-lettered schematic diagrams were crucial to the success of our courses, both for chemical engineers and also short courses to professionals. Without the quality lettered images, we really would not be able to teach any such courses. And we used a Kodak carousel slide projector and white on blue 2x2 slides to project them. I emphasize, no images, no courses. Well, Unit 1 in Bugbook 1 is sort of boring, so I'm going to show you images from Unit 2. Well, actually, these images in Unit 2 are pretty modest, pedestrian, so I will need to create a follow-up YouTube video that shows you images from the units in Bugbook 2. Some of them are not pedestrian. Some of them even might appear to you to be interesting. Well, I asked the question, what was important? Well, a major answer is my Leroy-lettered images. But there were other points that were important. Pedagogy, just what I felt I should teach as an educator was important. I spent a lot of time thinking about how I should organize my units, my experiments, and so forth. nobody helped me make such decisions. As an educator, I just did so instinctively. Okay, here are some examples. I don't need to talk much about them. Here are 4 gates, 2 input gates. I used these gate images both in Unit 2 and Unit 3 in Bugbook 1. And in Unit 2, I talked about a 2 input gate as one that had the ability to control input data and output it as it passes through the gate. So I called Unit 2, I forget, perhaps gated circuits. Now at the top I show the traditional logic images where you have 2 logic inputs and a single logic output. This is the traditional way of presenting gates. My gated signal inputs, well, were not traditional. And here are examples of traditional and gated circles with multiple gating signals. So it is these gated signal images that explain why and how you can use a multi-input gates. And this was, in my opinion, a rather unique chapter that showed a very interesting use of gates. Okay, here come schematic diagrams. This is really, I think, my first really good diagram, and I think it appeared as the last experiment in Unit 1. So, here was my first attempt to teach my students how to wire a circuit directly from a schematic diagram. Now, the key integrated circuit is the 7490 rectangle. Power, as a standard, I placed at the top. Inputs on the left of the box and outputs on the right. And here it is. Also, I show you a traditional 7400 2-input NAND gate, which I used as a gating chip or gate. So what I would have are 2 inputs. The signal input was the clock box. That I called an auxiliary function. And the logic 0 or 1 at the gating input was based on the use of a pulsar auxiliary function. Now, I was interested in the relationship between the gating input to the 7400 2-input NAND gate and the output from the gate. So I had 2 displays, auxiliary functions, number 1 and number 2. And finally, the really good auxiliary function, a 7-segment display. That, with the aid of the 7490 chip, would count from 0 to 9 and then roll over back to 0. And I'll keep on rolling over for as long as you had the patience to run this circuit. So, when I first wired this circuit, I was amazed. My reaction was, well, I don't know. I think amazed is not the correct word. Well, I did it on my office desk at home, and I could use another word. I was really impressed and thrilled. And incidentally, when my students wired this circuit and saw how it worked, they replicated my, my impression. This was, in my opinion, the most important experiment in Bugbooks I and II. I really made the point that digital electronics was something to be learned. In Unit 2, I followed up this diagram, and I used different gating chips. Here's a 7432 OR gate. Here's a 7402 NOR gate.